Wow. Kobe, bro. Wow. Yo. Man, man.
Yeah, I can hear you.
Oh, uh, yeah, I'm getting a strange number, at
For what?
B when what I did was after I found okay, let me start at A. At A, I used the x-intercept, um the roots, and then x plus 2, x minus 1, x minus 3 to find the equation of the formula, and then I got that. And then at B, I took the derivative of the formula to find the x values of the two turning points, and I
Okay.
found -1 and 5,
Negative
right?
one.
Yeah, -1, 5. Yes, and then I plotted back into the formula.
Well, wait a
Oh,
minute. You got a
uh,
negative 1.5.
yes.
So presumably negative one for A, and then a 5 should be for B. But do you think there's a 5 here in between 1 and 3?
Nah, I don't.
All right.
Okay,
Now,
maybe that's what I did wrong. Let me see. I don't know. Okay, cruise.
just try to figure out what you did here when you differentiated the function and obviously equated the function to 0. After equating the function to 0, your roots for that quadratic, which will be a turning point, your values of x in a sense for that quadratic, which will be a turning point. This one should lie between somewhere between 0 and 3. Right? It can be 2 or 2 point something, I don't know. And this one should lie somewhere between 0 and -2. I don't know what it's gonna be. But the 5 one is just a red flag.
Right.
Okay, just try to figure out what you did wrong here after differentiating, and then fine. Just try
Oh,
using
okay. I figured it out. I see what I did there.
a formula to find your root.
Okay, cool. I got tricks in the bag. Mm. Mm. Let's go there. I no longer walk by cruise. What? Yeah, I'm tripping for you. Oh, -4 squared. -4x -5. Why am I going wrong, bro? What's used to form that dog? That is used to form that dog. Something. No longer walk at cruise. You fix in a bag. Negative b. I got tricks in a bag. Plus, minus. A, B. I got tricks in a bag. Nah. Let's go 7-9, bro. Next equals 2. I don't know what that goes. Yeah. You know these things sometimes. I know, but I put that back into the formula like blood. I no longer walk, I cruise. I got tricks in the bag. Yes, I no longer walk, I cruise. How do you
Yes.
how do you do C, bro? I forgot the whole thing where you gotta do the thing on the maximum value.
How do you get what?
C, the maximum length of the line PQ.
PQ, you find the difference. The PQ distance will be the difference between the upper graph and the lower graph.
Like,
So the upper function will be the f of x and the lower function will be g of x. Notice there on top they said you have f of x equals x cubed plus bx squared plus cx plus d and x. That was supposed to have been g of x actually, not x.
Okay, yeah, that was a bit confusing.
Okay, that was supposed to be g of x. You can just fix here and just make sure that it's there. This should be g of x. G of x equals. So what you're going to do, you're going to take, this is the f, and this will be the g. You will take the graph of f and subtract the graph of g. That will be a distance pq. Right. Notice you can write your distance of pq as the pq for the distance, and you will take f of x and subtract the function g of x. Or you could just say d of x, because obviously you're going to get, when you take f of x minus g of x, you're going to get some function with respect to x. All right, meaning that your x will still be unknown. So you're not going to get any specific number of value in a sense for the distance. That it's just going to be some x values along. It's just going to be a function in a sense.
Sure. I understand.
D of x. And then the next thing, you would differentiate the function d of x and equate it to 0 for maximum, for the maximum values. You could do that for minimum value as well, but for maximum value, since they're looking for maximum value here. Notice if you differentiate that function, obviously it's going to be a cubic function, because what I'm thinking is that the 2x here will be subtracted from the linear 5x, so you're just going to have the 7x minus 6. So the only difference is that here the new function, the d of x, is going to be x to the power 3 minus 2x squared minus 7x.
7x, yeah, plus 6.
All right.
Okay.
So and then this will be a new function. We'll call that function pq if you want, but you can also call it d of x, and then you differentiate that function with respect to x and equate it to 0 for that, and then you're gonna find the values that you want to find. Obviously, after differentiating it, you're gonna get a quadratic, and then you find two values of x, and those two values of x, you could use the second derivative of the same function and equate it to 0. Not really equate it to 0, because that would be some point of inflation if it was an actual graph. You could differentiate it and make it undergo a second differentiation, the derivative of the derivative, and then test those values that you would find on the first derivative to figure out which one is going to give you a minimum value and which one is going to give you a maximum value. Remember, what you do for the second derivative, let's say it was a function f of x, so the first derivative will be f of x equals 0. This will be for the minimum or maximum value. All right, in this case will be minimum maximum length. However, this is going to help us to find just differentiate it, don't equate it to 0. If you equate it to 0, you'll be looking for the points. Just do that differentiation. After doing the differentiation, you find whatever it is, and then substitute the two values that you find here. For x will be some value, or x will be some. Okay, you get what I'm saying?
Sure.
All right, and then you just input there. If you get the second derivative, or f prime of x to be less than 0, this will give you the maximum value in terms of a maximum turning point. So in this case, it will be a maximum length. Right, if f prime of x, having inputted the value of x here, remember these values, would find them here. Okay, if we get a greater than 0 with a minimum value, in this case it will be a minimum length. Does that make sense?
Yep.
All right, so you can go ahead and do that.
Mm, mm, yeah. I love her, she loves me. Ba-da-da, 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 hey, hey, wait, the the one smaller than zero is the maximum or the minimum.
If it's less than 0, it's gonna be maximum. It's gonna give me a maximum value.
Okay. It's okay. I it's bigger than zero. Hey, it's a great day to be. Everybody is your name. Okay, so I got that. How how do I conclude this thing, bro?
Okay, so now if you know which value is gonna give you a value of x, which is gonna give you the maximum value
Right.
or maximum length in this case, you then, since they're looking, the question is actually looking for you to find the maximum length of PQ between the interval -2 and 3, right? It should lie between there,
Yeah.
and you can PQ obviously lies between -2 and 3 for the values of x. So you want to get the maximum. However, the other one is gonna give you some length of PQ, but it's not gonna be the maximum. So you're interested in the maximum length. So in order to do that, you have to use the value that's gonna give you the maximum length. And after that, you go back to your d of x function. And so you're looking for the d of that value. Okay, so let's say what value is it that you is gonna give you the maximum length?
Which value? The x
Yes.
value. It
Yes.
was 7/3.
7/3 gives you the maximum length.
Yep.
If you put 7/3 on your second derivative test, the d prime prime of x, what does it give you? Does it give you a positive number or a negative number?
It gives me a positive number. Wait.
If it gives you a
Oh,
positive number, it's a minimum.
oh, okay. Okay, sure. The one that gives me a negative number is -1.
-1. Then
Right.
-1. So we should then try and go back to the function d of x equals x to the power 3 minus 2x squared minus 7x plus 6.
Okay.
And then substitute. So we're looking for d of -1. That would be the maximum volume. Excuse me, maximum length.
We're going back to the
The PQ function.
function.
Yes.
Right. And we substitute.
Substitute -1. So we're looking for d of
Right.
-1.
Okay,
Yes.
sure. Let's see. Times everything. I love you. She told me. Right. I did that. And then I got 10. Good day, anyone if your name's
Okay, like I was saying, d of -1. I just noticed that I had muted. D of -1. All right, so 10 units is going to be your maximum length. All right.
right. Yes.
And now we can then move on to the D part of the question and then eventually the E part of the question. All right.
Wait, hold okay, hold on. Just to like to revise this real quick. When they ask me for minimum length of a line like that, let's say it's another question. I would first have to subtract the one graph
The other, yes.
from the other, and then once I get that, I typically that'll also be like another graph itself, but this graph represents the length, and so I would take the graph and then get the first derivative. Like once I get yeah, okay, sure. Once I get the first derivative, like I can oh yeah, once I get the first derivative, I can get the x values for those for that first derivative, but and by equating it to 0, right? And then the second derivative for that new equation that I found for the length, I use the same x values that I got from the first derivative, and I substitute it into the second derivative, and I get values to determine the minimum and the maximum. And then from there, once I discovered the minimum and the maximum, I then look at which x value gives me the minimum, the maximum, and then I substitute that x value back into the
yeah.
Okay. Okay, I got it. Sure.
So yeah, just like that. Notice, don't substitute it to the f of x function. So if interesting question, what
Like,
do you think if I were to substitute that -1 into the f of x, for example, into the f of x function? What do you think I'll be looking for if I do that?
what would you be looking for?
Yes.
Would you not be looking for the point at which this PQ intersects the f of x?
Yeah, I'll be looking at the y value for the p because the x value is let's say it is a -1. Yeah, but yeah, it will be more like I'll be looking
Okay,
for the output value,
sure,
and then
sure.
also if I substitute on the g of x, I'll be looking for the output value for the g of x. That's not what we're trying to do. All right.
Oh yeah, no, I get that. I get that. Okay, that's interesting. Yeah.
Right, don't confuse the two. All right, I think now we can come here and then eventually we'll come here. Now again, if you have questions, you can still feel free to ask.
Yeah. Yeah. The graph of f is concave down at x smaller than k. Calculate the values of k. Concave down. Concave down. Concave down. Maximum. It's like this. Other bigger than 0. But that's x. Let's go, bro. Let's go, bro. Let's go, bro. Da da da. Down. Hey, it's a good day to be anybody if your name is me.
Remember that concavity is basically determined by a point of inflation. So the what's separating concave up and concave down is the point of inflation. All right. So maybe from a point of inflation, is if we have a function that looks like this, which has a maximum turning point and a minimum turning point, with a point of in between, we separate the concavity. So I'm just going to scroll down a little bit. All right.
Okay.
And just illustrate some things for you here.
Okay.
As far as concavity is concerned, and let's say a function that looks like this, right? Okay. So I have a maximum turning point, that's the point, and a minimum turning point is the point, all right? So this is my minimum turning point of my minimum value, and that my maximum turning point of my maximum value, all right?
Right.
All right. So now concavity, here I have the point of inflection. So concavity is separated by a point of inflection. If I have something that looks like this, just to illustrate the point, if I have something that has, I think I'm going to use a pencil still. If I have this part up to the point of inflection, right? If I were to draw the tangent lines, this tangent line were to be drawn. This tangent line, we're already familiar with this one already. This is the tangent line that gives us the slope of 0. All right, but every tangent line that I'm going to draw here, right? Make this one a little bit small. Every tangent line that I'm going to draw on that concavity, right, will be above that concavity, in a sense. All right, so I could repeat those tangent line. This one will lie here. Doesn't matter how they lie, basically. This one will lie here, and just make sure I duplicate another one. And say this one will lie here. Just 3 will do. All right. So you can see they are lying above the that tangent, that curve or that concavity. Right. So this is where we have what we call concave down. Remember, the concave down is associated with the maximum turning point. All right?
Yes.
When you're looking for where you have concave down, just look at where your maximum turning point is. There you're going to get your concavity down. All right? Concave up will be the opposite of that. Your tangent line should be drawn below there. Right? So again, what's separate for us, the concavity will be like I said, the point of inflection, that's right there. Let me just use another color for this so that I can make sure. So that's your point of inflection that basically separates the concavity. So now this point of inflection is very important. Let's say the point of inflection is at x equals a. All right, so the value of that x at that point of inflection equals a. So we have concavity. If you're looking for a concavity or a concave down, remember this concave up again. So for a concave down, remember concave up with the minimum turning point. So our concave down would be from the point of inflection value A to the left. Can you see that? Now, when I move from the point of inflection value A to the right, I'm no longer getting my concave down. I'm actually getting my concave up.
Right. See what you mean.
All right, so concave up and concave down is separated by a point of inflection, which is different from the idea, if you want to think of it, of f prime of x greater than 0, right? Now, f prime of x greater than 0, f prime of x equals 0, f prime of x less than 0. Similar to what we just talked about right now, but they're not really asking for the very same thing. All right.
Yeah.
And I'm going to show you what we mean by that. Okay, so if we're looking for f concave up and concave down, we use the point of inflection to that's my idea. All right, it's like something I kind of gathered along the way, just to sort of think of it. So the concave down will be from the value A to the left. So if I'm looking for the concave down, I'm going to be looking for any value less than A for x. So all the values on the left of A for x will represent my concave down going here. So all the values of x of the domain to the left will represent that. However, all the value of the domain to the right will represent my concave up in that manner. Okay, so that represents that represents that. Does that make sense?
Yeah.
So hence you have a question that looks more like this. All right. So the graph of f is concave down for x less than. So clearly they're just telling you what they're looking for here. They're looking for the point of inflection, the value of x, rather not the entire point, but the value of x for the point of inflection. The x will be some value k, and if we have the point of inflection, we'll know that our value k will be, right? And that will be it. And then that will help us to do this next question. All right. The next thing I wanted to talk about was this f prime of x. F prime of x equals 0 here. All right. We've already done that. F prime of x equals 0. This 0 is the gradient. All right. Once we see this f prime of x equals 0. This 0 here, like we talked about the last time, again, we're reiterating this concept, just making sure that you're getting the whole idea. We've talked about this, that if we have f prime of a equals m, f prime of a equals m, the a here is the value of x of your turning point, key, right? So if I say f prime of x is equals to 0, I'm literally saying this is my gradient, obviously that's my slope. Do you understand what I mean? But it's a slope value x equals a. It's important. That's why we find, when we're looking for the turning point, we're finding the f of x, f prime of x, excuse me, which is the derivative of the function, and we are saying the derivative of the function is a flat slope, which is that gradient of a straight tangent line. So the tangent line kind of helps us appropriate the gradient of this curve or your cubic function in a sense. Okay, so this value here, right, that we solve for when we equate this to 0, which is the gradient. Remember, it's not the same as the 0 for letting the function y or f of x.
Well, yeah, most definitely.
Right.
Sure.
Now, this one is for the gradient, it represents our slope. Now, this representing our slope, we know the slope is going to be defined as some value x. That's why when we equate the slope we solve for x, those values x are the ones that are going to define our slope, or where the slope will be at the point of contact of the function and your tangent line. That's why we get those values that you found when we find the turning point, for example, in turning point A and B. All right. So that's what we did. Okay, so you already know this. We've talked about this, right? We've talked about this so many times. When we started this, the whole point, the whole picture I wanted to get you to get was that. So we know what this is, all right? It's there and there, but we don't know what this is, okay? And I just want to sort of kind of show you what we mean. So f prime of x greater than 0. They're looking for where the function is basically increasing. So f prime of x less than 0, they're looking for where the function is basically decreasing. So where is it actually there? All right. So f prime of x is greater than 0 will be here, all right, and also here. All right. So here we have f prime of x positive, and here we have f prime of x positive. Now, what do we mean by that? F prime of x is our gradient, is our slope. Can you see? Look at the tangent line that I just drew here. Do you think it's a negative slope, that one?
Going this way. No, it's a positive slope.
It's a positive slope. What about that one? Do you think it's a negative slope?
Nah. It's a positive slope.
But what if I draw a slope here? Do you think it's going to be a positive or negative slope?
It's going to be a negative slope.
So this is where, at this point here, is where we find f prime of x to be negative, all right? Because that's where we get a negative slope. Do you understand what I'm saying?
I get what you mean. Yeah, okay.
Yes.
Yeah, I understand. Sure.
Okay, so if they ask you a question, for example, right, and you're still going to use your maximum turning point and your minimum turning. Your maximum turning point, your minimum turning point are the points that you're looking for every time they ask you this question. But when they're asking for concavity, you're going to look for the point of inflection, all right? So let's say they are looking for where f prime of x is, where you have your f prime of x positive, and they usually say this is where the function is increasing. For which values of x is f prime of x increasing, all right? So you can see the minimum turning point, the maximum turning point are our point of demarcations. They helps us locate, okay? From here going to the right, you can see f prime of x is increasing, and from here going to the left, you can see f prime of x is what?
It's increasing. Sure.
But in between these 2 points, f prime of x is what? Is decreasing. All right, so for which values of x is that? So we're gonna have x is less than the point here, which is the maximum turning point. We're looking for the values of x, by the way. In that case, will be this point here. Okay, now let's just say the point of what do we call? Let's say that point. I'm just locating. Which ones did you find, by the way? I think we were able to find your maximum turning point. What values were there? Just so we can. Your maximum turning point. What was?
My maximum turning point was okay. Let's see here. was negative 0.79
Right,
and
0.79,
8.
right? So
Like,
would be say that we have f prime of x positive
oh,
for x is less than negative, or on the left. Can you see going to the left? Starting from here, going to the left,
like,
and that we have is a negative 0 comma. I just want to be in context with this question.
sure.
0 comma what?
Negative 0.79.
Negative 0.79. Going to the left, or negative 0.8, right?
Yes,
Or
yes.
x greater than, or x should be greater than, what was your minimum turning point?
2.12.
2.12, all right. At the right of 2.12, all right. At the
Like,
right of 1,
2.12. Sure.
function is having a negative gradient or a negative slope between those very points. Okay, so I'm going to put negative 0.79, and there's going to be 2.12. You could use the interval notation,
Notation. Yeah.
0.79 and 2.12. All right, going to the left. Obviously, going to infinity, negative, going to infinity, positive. All right. Okay. And here you can also use, you can either use your set builder notation or your interval notation, whichever one you prefer. But I think that makes sense, right?
Yeah, it does.
Okay. All right. Another interesting question is, like, I would also like for you to write this down so that you don't forget it. This annotation that I know it looks dirty. I was saying a lot of things. Perhaps with the ideas that we've previously built, right? So I was coming at you slowly. Now remember, like I said, I always say I don't know what they're gonna give in an exam, but I'm just giving you a picture in a way that you'll be able to sit down, look at a paper, and say, "No, I know what's happening here," right?
Sure.
I'm not trying to give you specific things, or maybe to answer specific questions that we're looking at. So, like, if I feel like I should go outside of the context of what I'm trying to do with these questions and explain something else, I'm always gonna do that. But I hope this makes sense, right?
No, it makes sense.
Okay. All right. Now you will do E. And what's interesting about E, while you write the rest of the information, just make sure you have it on your book. What's interesting about E is that they want you to determine the equation of F at the point of inflection in the form of y is equals to mx plus c. All right. So in order to find, they're looking for you to find the tangent at exactly that point. Do you see that? You
Yeah.
already
Wait. Oh, yeah. I see that.
already have that point, right? You just need to know what is the gradient at that point. And the gradient is not going to be a point, obviously. Here you're going to give them that point of inflection. I didn't calculate it for you. I wanted you to do that, all right? And then, now that point of inflection, if you get the value for x, let's say value for x equals a, that a will help you to find the output value, and then you go back to the original function, f of x, and substitute and get the y value. So the point of inflection is both the x value and the y value, okay? Now at that point will help you to get your constant of your y equals mx plus c, right? But your gradient is an interesting thing here. All right, because the gradient is defined at the point, but the gradient here, unlike here, which is a 0, and here, which is a 0, is going to be some number. All we know is that the gradient is going to be negative, all right? Just as the gradient here is going to be positive and here is going to be positive, here, however, is going to be negative gradient. So once we get that gradient, and how do we get that gradient? We get that gradient by knowing we have already differentiated the function somewhere up here to be able to get that. But now we don't want the differentiated function or at what is those turning point at 0.07, at 0.79, negative 0.79, and 2.12. This gives us the zeros. They give us the gradient of 0, right? We want the one that is going to give us the gradient of a non-zero but a negative nonetheless. and that's there. So we're gonna input the value of the point of inflection in your differentiator function, and the output value, or whatever you get, is gonna be your gradient. Does that make sense?
Yes, that
Carlos?
makes sense. Okay.
Okay. All
Let
right,
me
please
just put it
go ahead.
down. Right. Okay. Yeah, I think I got it. Let me. Okay. Yeah, I think I got it all down. Oh, hey, my microphone.
All right. Remember, we're looking for the point of inflection.
Point of
right?
inflection, sure.
So we'd find it at the second derivative. The first derivative, by the way, was what was it? 3x.
It was
3x squared. Is that 4x?
yeah, 3 squared negative 4x and minus 5.
Okay. And then you did find on the first derivative, you did find your maximum and minimum turning point at f prime of x equals 0. And then you differentiated these for the maximum and minimum for local maximum and minimum turning point, right?
Yes.
You did that. All right. So right now I'm looking for the second derivative, right? So this should be our part C of the equation. All right. So part B we did this, and then part A we're supposed to find the equation of which did. All right. So the second derivative will be 6x minus 4, right?
Cool. Yeah.
So at the 6x minus 4, obviously we're looking for f prime of x to be equated to 0 for point of inflection. Right, so we're gonna take 6x and subtract 4 equate to 0, and then 6x equals 4, and then x equals 4 upon 6, which is going to give us the value of x is I think of 2 divides 4 and 6 into 2 and 3. All right, so this is the x value of the point of inflection. So we're gonna go to the function and then find f of 2 over 3. All right, calculating the f of 2 over 3, what was your output value?
Let me quickly do that now. Sorry for wasting time.
Make sure you do substitute at f of 2 over 3 at x to the power 3, which is 2 over 3 all to the power 3 minus, I think that was 2x, 2 into 2 over 3 all squared minus 5x. So that's going to be 5 into 2 over 3 and then plus 6. So we should be able to get f of 2 over 3. Now I can also try to pull out my calculator and we'll see if we can punch it together. Calculator like this. All right, so there's gonna be 2/3 to the power of 3.
To the power of 3.
And then minus 2 into 2/3 to the power of 2. Excuse me. And then minus is it 5, right? Into 2/3.
Oh, fix the
0.96.
No. Fix the slow down there, Tiger. No, wait, hold on. Check your calculator, bro.
Did I do something wrong?
Yeah.
I do wrong.
The 2 over 2.
Oh, 2 over 2.
Yeah.
All right, thank you. The 2 over 2 part. All right. That's going to be 2/3. So it's a 53 over, it's 2.07, 56 over 27. Okay, 2.07. So 56
over 27.
Over 20?
No, 27. Yes.
Which is 2.0. Is it 0.7?
It's
Right.
2.07.
I'll just set it to writing it as a fraction.
As a fraction. Sure.
The interesting part is already the other question is answered. I was just the other question was x should be, they said x should be, did they say x should be less than k for concave?
Right.
So x should be less than 2/3, right? I was actually trying to answer the D, in which we have y equals mx plus the constant c. As long as it touches this point here of inflection, our gradient basically just does that. Let me just try to find a pencil to do that. Our gradient will be doing that. All right, just so it can make sense. All right, let's say we have that one point at the point of inflection there. So here we should get our slope or our m. All right. So to get our slope, we already know the point is 2/3 and what? 2/3 and 56/27. So, but what we're looking for is what will be the gradient. Obviously, the slope there we know is going to be a negative, right?
Yeah.
But again,
yeah.
f prime of a equals some slope m. So the a will be the input value on our differentiated function. So we do have our differentiated function, except now the a that we're putting here is not these ones that we found here, because those are going to give us a slope of 0. Is the one that we found here, which is the 2/3. You will see the slope is going to be some negative number. All right, simple as that. So we're looking for f prime. We've already calculated the f prime facts. Okay, let me just f prime facts here. The f prime fact equals 3x squared minus 4x minus 5. 3x squared minus 4x minus 5. So I'm looking for f prime of 2/3. Why? This number is important because it's going to give me the gradient at that point. You understand what I'm saying? The gradient of this thing keeps on changing. And key things is here, I'm not going to find a 0, right? I'm not trying to find the slope to be 0. It's not going to be 0, right? But however, the slope is going to be some negative number or number below 0. So I'm going to see what it is, all right? So did you get that part?
Yeah, I'm getting it.
Okay, right.
I'm getting it, sure.
All right. I thought maybe I lost it. So 2/3 squared minus 4 into 2/3.
We're using specifically this sort of the derivative of the function f of x because we're looking for the gradient.
Yes.
At that. Okay, sure. At the point of inflection.
At that point, you see the gradient at the point, the one that you've already done. I think it was a negative 0.79.
Yeah.
The gradient at those point, negative 0.79 squared minus 4 into negative 0.79.
Yeah.
This should give you 0. That 0 is your gradient. Do you get that?
Sure.
Sorry, f prime, and then f prime of the other one I think was 2.12. Also 3 into 2.12 squared minus 4 into 2.12 2, and then I think it's a minus 5. Okay. Also that one should give you a 0. All right. Is the only difference that it won't give you 0 by some number close to 0 point something, whether to the left of 0 to the right of 0, is because we're just using the decimals. All right, so these numbers you're just gonna get exactly the zeros. I just wanted to make sure that point is clear. All right.
No, I get it.
Okay. So here we're gonna get some number as well. So for f of 2/3, that number is gonna be our gradient at that point. At this point right here. Does that make sense?
No, that makes sense.
All right. What number is that?
Negative 19/3.
Negative 19/3.
3.
All right. So negative 19/3 is that. All we need to do is to use the y equals mx. The gradient is negative 19/3x plus the constant c. Use the point of inflection. Right.
Yeah.
Of inflection to find the point of inflection. Remember was what? Was 2/3.
Was 2/3.
was it 57? 56 over 27. 56 over 27. Find the constant c. This one will go for the x, and this one will go to to find the constant c. Does that make sense?
Yep, that makes 100%.
Because the tangent touches the function at one point, touches the graph in this case at one point. Now, we've kind of took more time on this one, but we did more than just basically answer this question in a sense.
So,
All right.
no, you have put a lot of things into perspective.
Okay.
Sure.
So I'm thinking next time when we do this, we're just gonna go to the rate of optimization and rate of change, right?
Right. And you explain to me what that is.
Yeah, it's not gonna be any different to what we were just doing here. It's just like, I don't think we're gonna spend more time there, obviously, because we're kind of sort of polished into some ideas that
Sure.
are important for this whole part. Okay, and they will come going from here onward. Okay, so that's it for tonight. You have a good night.
You too. Thanks.
Yeah.
Take care.
Okay, guys, if you're watching live this on YouTube, please make sure to like and subscribe, and just make sure that some of your friends come to hear about this. All right, so these classes will be held every Saturday, Sunday, just around this time. Let's say 7 o'clock. 7 o'clock to after 7, between those times, I'll be doing these live sessions until you guys write your exam. So it's important that you notify your friend, you tell your friend, and just make sure that a lot of people come to know about this channel. It's this channel is still new. I just started this channel recently. Actually, I started it at the beginning of the year, but I was just reluctant and just at some point just lazy to put in this content. So I figured I don't have to actually do recordings and then just put those videos here. I could actually do those since I'm not lazy when I'm doing it with learners. So I just decided instead, how about, I know you guys can't see my face, but that's my face right there. How about I do these stations and just make sure that I go live, that you guys can see this, and later on I can just leave them there on YouTube for you guys to come and refer later on. So so this is what I'm gonna be doing every Saturday, every Sunday, around this time. So I'll be consistent around this time. I'll be covering grade 12 only, since my student around these times are grade 12. By the way, I do have grade 11 and grade 10s for both math and physical sciences. All right. So but for physical sciences, some of the classes I'll be holding on school. So when I do that, I'm just gonna make sure that I just record the video for you during class sessions, and then later on I'll upload them for you, just to kind of let you in what we've been through that day. And if you guys would need some help, you can just feel free to email me. I'm gonna also make sure that I link up my email address, and I think I did link it up on some videos as well, but I'm gonna link up my email address as well when I'm doing these classes, so that you guys can find me. Or you can also find me on Facebook. Facebook, just search for Aubrey. I'm just gonna write my name down for you to see. Aubrey, and then surname. This is not the actual name that I use. Tariq Imhotep is not actually the name that I use on my socials, actually. But I think I should change all my socials and just go by Tariq Imhotep. That will be fine. However, on YouTube is Tariq_Tutor, and you'll be able to find me there. Just again, make sure to like and subscribe, and so that you can keep getting more of this content. And I would really appreciate if you guys can do that. All right, like I said, this channel is still small, but we intend it to grow so that we can reach a more larger audience to what is it that we're actually doing. All right, like I said again, on the future, before we begin any classes, I'll just make sure that I'll link my email address for those of you who would like to contact me, and I also like to, and I would link also my my social handles as well on here for you guys to be able to see that. All right, so I hope you enjoy this lesson and you keep sharing it to other people, and then just make sure that you tell a friend, and a friend will tell a friend, and that's how the good news spread. All right, you guys have a good night. I'll see you next time we do this.